See this. What is the question number? That question. A child has a die whose six faces show the letters as given below: A, B, C, D, E. Again A. So she is having a die. You tell me, in general, a die has six faces like this. Of course, all flat faces, all faces have equal chances of turning up, right? Of course, die, cubical die in general. So that is correct. So any face may come up. So all faces have equal chances. So probabilities are 1 by 6, 1 by 6, 1 by 6, 1 by 6. All possible outcomes means 1, 2, 3, 4, 5, 6 we write. Here, of course, in this particular die, what are the faces? A, B, C, D, E, A. These are the faces, right? A occurred twice, of course. A. So, anyway, if you throw this die, any face may come up. So, for this to come up, what is the probability? 1 by 6. This to come up, 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 1 by 6. Right? Probabilities 1 by 6. Anyway, of course, what is the question he is asking? The die is thrown once, only once. What is the probability of getting A? Probability of getting D? That is the question. You see, probability of getting A, let us find out. See, our formula is favorable by total. Coming to this denominator, total. How many total faces? How many faces? 6 faces. 6 faces. So total is 6. Coming to numerator, favorable. Favorable. How many are favorable to this? That is, how many A's are there? 1, 2. 2 A's. So 2 faces are favorable. So our numerator is 2. So this is 1 by 3. Second part, probability of getting that face to be D. Of course, denominator is total 6. Coming to numerator, how many are satisfying this condition? That face to be D. How many D's are there? Only 1 D, right? 1. So 1 outcome is favorable. So 1 by 6 is the answer. That's all. Question number 20. Next question. See this. Question number 20. See, one rectangle is there. Length is 3 meters. Breadth is 2 meters, of course. Suppose you drop a die at random on the rectangular region shown in the figure. Okay, in this rectangular region, you have dropped a die. What is the probability that it will land inside the circle with diameter 1 meter? Of course, inside a circle. This is 3 meters. This is 2 meters. Inside the circle, let us say this is circle, and diameter of the circle, let us say D, is how much? Given inside the circle, diameter 1 meter. Diameter is 1 meter. Okay. See this. You have dropped a die, right? This die, if you drop this die like this die may fall anywhere, right? Anywhere, but he is talking, he has thrown this die inside this rectangle. So this may fall in this complete area, anywhere in this complete area, right? Complete area. So probability, what is the probability? What is the event now? Inside the circle, diameter 1. So probability for this die to be placed inside circle, that is my question. Coming to the formula, denominator is total. Intuitively we can say that denominator is total. Total means this total area we can consider, right? Here in this case we are considering areas, right? In the denominator, total area means total this rectangular area. What is the area for this rectangle? Length into breadth, right? Coming to numerator, numerator is favorable basis. What is this event inside the circle? That is a event, right? die to be placed inside the event means you tell me what is the favorable. That means that die should fall the area containing this circle. Area containing this circle, right? You tell me what is the area containing this circle, that is favorable. You tell me the area in meters, that is pi r square is the area of the circle. Of course, diameter of the circle is given. If diameter d is given, pi d square by 4 is the formula, right? Radius r is d by 2, so pi r square means pi into d by 2 whole square, d square by 4, 5 d square by 4. That is pi into what is the diameter? 1. So 1 square by 4 by length into breadth, 3 into 2, that's all. LB I have written here, right? Now this is pi into 1 by 4 into 3 into 2. 4 3s are 12, 12 2s are 24, that's all. So we answered pi by 24. This is of course meter square, you can leave that. Pi by 24 is the answer. Next, coming to question number 21. Of course, we know what I am going to write here. Of course, I want to do question number 21 now. I will write here formula for probability as favorable by total. Favorable by total. Yes, coming to question number 21. See this. You see, you look into your book. A lot consists of 144 ball pens, of which 20 are defective and others are good. 144 pens. Total 144. 20 are defective, D, plus remaining 124 are good, right? Okay. Noori will buy a pen if it is good, but will not buy if it is defective. Okay. The shopkeeper draws one pen at random and gives it to her. So what the shopkeeper is saying, he is giving one pen out of this 144. Noori is opening the pen and writing. If it writes, okay, she can decide that it is a good one, she will take. If it does not write on the paper, she can decide that it is a defective one, she will not purchase. That is the condition. Okay, he is taking one by one from this. First question number 1. What is the probability that she will buy? Probability that she will buy, Noori will buy means when he will buy. If it's a good one, she will buy. Indirectly, he is asking us to find out the probability for a good pen, right? Now tell me, what is the denominator? Total 144. Coming to numerator, how many are favorable to this? That is, how many good ones are there? 124 are good, so your favorable is outcomes are 124. So numerator is 124. That's all. That's all, right? This is your answer. Now coming to this next question, question number 2 of 21. She will not buy it. Probability that not buy. She will not buy means when she will not buy. If this is defective, she won't buy. Indirectly, he is asking us to find out the probability that the pen to be a defective one. So tell me, total is 144. Coming to numerator, how many are favorable to this one? That is, how many are defective? 20 are favorable, right? That's all. 20 are defective, right? That's all. 4, 5, 6. So this is the answer. Now coming to question number 22. Question number 22. Refer to example 13 point. Of course, you look into your textbook. Refer to example 13.1. Complete the following table. Is giving one table like this. sum to event. What is the event? Sum on two dice. That is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is probability. Of course, here it is given 1 by 36. Here for 8 it is probability is given as 5 by 36, and for 12 this is given as 1 by 36. What you are supposed to do? Complete the following table. You have to fill this. See, question number, of course, is referring to example 13.1. Let us go to example 13.1 of the textbook. Right? This is example 13.1 means this one. See this figure. See this figure. 13.1 means, what is the question? Two dice, one blue and one grey, are thrown at same time. Write down all possible outcomes. What is the probability that the sum of the two dice appearing on the top of the dice is this? See, all possible outcomes. If two dice are rolled, all possible outcomes are 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2. We know, we have seen that. Na? How many total? 36. 36, right? 6, 6, 6, 6, 6, 6 are 36, right? So denominator will be always 36. What is the, see, in this question, he is finding out sum on two dice, right? Sum on two dice is 2. Find the probability. You see, of these 36, which combination will give sum 2? This only this one. See, 1 plus 1 is 2. This is sum 3, sum 4, sum 5, and so on. Nowhere else you will get sum 2, 1 plus 1. So only one outcome is favorable. So your numerator is 1 here, 1 by 36. In the same way, you tell me probability of sum 3. You can write now. First one may be 1. If first one is 1, second one should be 2. Sum 3, you tell me sum 3 means 1, 2 are possible, 1, 3 is possible, 2, 1 is possible, right? Any other possibilities? Sorry. 1, 2, 2, 1, that's all. 1, 2, 2, 1. That means 1, 2, 2, 1 means only 2 possibilities, but total 36, right? Here you can see in this, here also you can see 1, 2, 2, 1. See this one. Any other possibilities is there? No. All are sum greater than 3. Now sum greater than 4. You can see sum 4. Sum 4 means you can write. If first one shows 2, second one should show 3. 1 plus 3 should be 4 na. Is 4 na. 1 comma. First one increase this 2. We will calculate this. 3 we will calculate this. Tell me, 1 comma 4 is 1 chance, 2 comma 2, 3 comma 1. If you increase still further, 4 comma 0 is not possible because sum to be not. So 3 chances are there, 3 outcome, 3 by 36. Of course, from here also you tell me sum 4, 1 comma 3, 2 comma 2, 3 comma 1. These 3 are favorable, right? That's all. Remaining are not favorable. In the same way, of course, you can find out sum 5 means, of course, you can find like this also. You tell me like this in this, we will try this. Sum 5, tell me, starting from 1, increase this, and so on. If 1 is on the first die, sum 5, to get sum 5, second die should show 4. Yes, if 2 is on the first die, second one should show what? Second one die should show 3. 2, 3. Sum is 5, right? In the same way, 3 comma 2 possible. 4 comma 1 is possible. 4 chances of 4 by 36. In the same way, you can find out from this picture also. 1 comma 4, 2 comma 3. This all these will give you sum 5. So 4. In the same way, same method. See 6. Sum 6, see this 1, 5, 2, 4, 3, 3, 4, 2, all these 2, 4 plus 2, 6, 3 plus 3, 6, 2 plus 4, 6, 1 plus 5, 6, 5 plus 1, 6, 1, 2, 3, 4, 5. So 5 by 36. In the same way, tell me for 7. 1 plus 6, 7, 2 plus 5, 3 plus 4, 4 plus 3, 1, 2, 3, 4, 5, 6. Sorry. In the same way, of course, he has given this. For some 8, 5 by 36. See, this is mentioned. 2 plus 6, 8. 3 plus 5, 8. 8, 8, 8, so on. This is 1, 2, 3, 4, 5 outcomes. The same 9, of course, this one. 3, 6, 4, 4, 5, 5, 4, 6, 3. 1, 2, 3, 4. Sorry. 4 by 36. In the same way, 10. 3 by 36. 11. 5, 6, 6, 5. 2 by 36. 12, of course, is given. Only one chance. 6, 6. 1 by 36. That's all. Question number 22 is over. It's over. Question number 22, of course, second part is there. 22 is also there. 22, 2. Of course, my favorite formula. Probability is favorable divided by total. Favorable by total. Yes, question number 2 of 22. A student argues that there are 11 possible outcomes in this question. 11 possible outcomes. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Therefore, each of them has a probability 1 by 11. Do you agree with this argument? Justify your answer. See, only 11 he is saying. 11 possible outcomes. Justify your answer. See, for each, let us say, when we throw a die, 6 outcomes are there. Each is having equal chances of occurring, right? Equal chances of occurring. So, probability for getting each phase is 1 by 6, 1 by 6, 1 by 6, 1 by 6. We have discussed it. So, that means all are, of course, elementary events and all are having equal chances of occurring. They are equally likely events. For equally likely events only, probabilities are same, right? Here in this case, they are not equally likely. Getting some and 2 and getting some 8 are two different events, and they are not equally likely. They are not equally likely. Their probabilities are different. Na? Chances of occurring are different. See, in 5 cases, you have got some 8. In 1 case, you have got 2, some 2. So, they are not equally likely. So, they are not equally likely. So, they do not have equal chances of occurring. So, you cannot accept the statement that the probability is 1 by 11. That is wrong. Clearly, probabilities are calculated now. We have calculated that. So, this is wrong. Because why you are not accepting that statement? Because these events are some 2, some 3, some 4, etc. are not equally likely events. Now coming to question number 23. 23. A game consists of tossing 1 rupee coin 3 times and noting its outcome each time. Hanif wins if all the tosses give the same result. That means 3 heads or 3 tails, and loses otherwise. Calculate the probability that Hanif will lose the game. That is the question. You tell me, so of tossing 1 rupee coin 3 times. 1 rupee coin 3 times. Head, tail, right? You tell me if 3 coins are tossed at a time or 1 coin tossed 3 times, what are possible outcomes? Tell me. Let us say first coin shows head. How about second coin? Second coin may show head or tail, right? It will not depend on first coin, result of output of first coin. It may show head or tail. So again, this one also head or tail. Let us say first coin shows head, second coin shows head, third coin head. One case, head tail. Another case, tail head. Another case, tail tail. Another case. All these four have head and the first one. Let us say first one shows tail. Second one may show head or tail. This one also may show head or tail, right? Head, head. But again, four. These four are possible again here. Head, 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 tail, tail, head, tail, tail, right? So, how many? Any other possibilities? No. So, head, H, H, and so on, so on, so on, so on, so on. So, total how many? Eight outcomes are there. 4 plus 4, 8. So, now what is the question? Question number 23. Calculate the probability that Hanif will win. Okay, when he will win, he will win if all the tosses give the same result. That is, all heads or all three tails. Yes, three heads or three tails. That is his question. Tell me, what is the total denominator? Total. How many outcomes are there? 8 outcomes. Denominator is 8. Coming to numerator, all three heads or all three tails, how many are favorable to this condition? How many are satisfying? All threes. All threes means this event. All tails means this outcome. These two outcomes satisfy this condition. So favorable. How many are favorable? 2 are favorable. 2 outcomes are favorable. So your numerator is 2. So your answer is 2 by 8. That is 1 by 4. Next, coming to next question. Question number 24. A die is thrown twice. What is the probability that... Yes, next question number 24. A die is thrown twice. What is the probability that 5 will not come up either time? 5 will come up at least once. This is the question. We know a die is thrown twice or 2 dice are thrown once. Both will give the same result, right? We know. You tell me what will be the outputs if 2 dice are thrown. Yes, we know 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, 2 1, 2 2, and so on. 3 1, 3 2, 3 3, 3 4, 3 5, 3 6, 4 1, 4 2, 4 3, 4 4, 4 5, 4 6, 5 1, 5 2, 5 3, 5 4, 5 5, 5 6, 6 1, 6 2, 6 3, 6 4, 6 5, and 6 6. These are all possible outcomes. How many are there? 6 6 6, so on 6 times. 6 6 are 36 outcomes, right? So total 36. Now first question, 5 will not come up either time. Of course, what is the we know what is the denominator. Out of this 36, anything may come. So total outcomes is 36. So denominator is 36. Coming to numerator. Now 5 will not come up either time. That is the event. So probability that no 5 on either time. That means first die
there should not be 5. On second die also there should not be 5. So 5 something or something 5 or 5 5 should not come. Tell me, here do you find 5 here? 1 comma 1 so on, 5 is there. Yes, yes, here this row, here this row, this one, this row, this one, this row, all in every outcome there is 5 5 5 5. This one only here is there, right? So what you have observed, this complete row and this complete column, 5 is there. Our what is favorable to our event now? 5 will not come up either time, so there should not be 5. So we don't want these ones, right? Remaining are favorable to our event now. What are how many are favorable now? 1 2 3 4 5. 1 2 3 4 5. 1 2 3 4 5. 1 2 3 4 5. That is, of course, again 1 2 3 4 5. That is 5 5s are 25. That's all, 25. So 25 are favorable. Coming to second question. Denominator is, of course, what is 5 will come up at least once. At least once, probability of at least 1 5. Tell me, denominator is of course 36. Coming to numerator, what is, how many are favorable to this event? At least 5 means yes. What you thought is correct. All these have at least 1 5, right? All these have at least 1 5. No other outcome is having 5, right? So how many? 1 2 3 4 5 6 7 8 9 10 11. 11 are favorable. So our numerator is 11. 11 by 36, right? That's all. This is question number 24. See, one another way also we can solve this question. See, if you solve this question, let us say, because this is easy, at least 1 5 is, of course, giving probability 11 by 13. This will be complement of this, is it not? Simply, these two are complementary events. So 1 minus probability of the event will give you the probability for the complement event. So 1 minus 11 by 36 should be the answer. This yes, clearly 1 minus 11 by 36 is 25 by 36, or 1 minus 25 by 36 is 11 by 36. If you find the probability for this event, you can find the probability for this event in that way also, 1 minus 25 by 36. Of course, whichever is easy you follow, right? We have understood, I think, right? Next question.
So, question number 25 1. So, this is if the following arguments are correct and which is not correct. So, this argument is not correct because yes, if two coins are tossed, of course, we know tail, tail are possible. Of these tail, head, of course, these two outcomes have one head, tail each, right? But getting that event one at one head or one tail is twice likely. Is twice, that means there are two such outcomes, right? But the remaining ones, that is both heads, both tails, is one. So they are not equally likely. So the argument is wrong. The next question: if a die is thrown, there are two possible outcomes, an odd number or an even number. Therefore, the probability of getting an odd number is 1 by 2. That is correct because we have seen already that if a die is rolled, even numbers possible are 2, 4, what are the even numbers? 2, 4, 6. Total number of outcomes is 6, denominator is 6. Getting an even number is, of course, 2, 4, 6 are even numbers favorable, so 3 by 6. In the same way, that is 1 by 2. Of course, getting an odd number is also the same. 1, 3, 5 are odd numbers. So 3 by 6 again probability. Again, what we have observed is these two outcomes, that is these two events, that is even and odd, both have, if you consider the all outcomes, 1, 3, 5, 2, 4, 6, all these two outcomes, sets of outcomes together will form the complete set of all possible outcomes, right? So they are complementary events, and of course we can accept the fact that probability is 1 by 2 for even for this odd number and getting odd number. So this is Correct.